Hello, hello everybody. Good morning, good evening, good afternoon, good night. I don't know because these sessions are online, so there are people over all the world here connected. So first of all, thank you very much for coming to this Kubernetes Master Course number 1. And remember that on Wednesday we've got the number 2. Let's start. Today it's the course number 1, and before that I'm going to share with all of you all the links that I've got here. The first link is for the Kube tutorial. Kube tutorial are all the instructions that you can follow to run yourself this tutorial after the session or at home, at work, and so on. Basically everything that we explained today and on Wednesday, it's in this link. And of course, I'm also going to share with you the slides. And here are HTTPS. These are the slides. So if you want to follow the slides, then you can also go here. Then, just the upcoming definition schedule. Today we are here, Kubernetes Basics. At the same time on Wednesday, but remember that you need to register for the Kubernetes Elementary as well. We've got the part 2 of this tutorial where we're going to learn more advanced topics. And then the next week, we've got Kafka and the Istio. So after this Kubernetes course, it's a good thing to learn Istio because, it expands what you can do with Kubernetes. And of course, if you want to learn Kafka, all these even source architectures, how to start streaming your changes, then Kafka course is also a good thing. My name is Alex Soto. I work in Red Hat, author of Testing Java Microservices and Quarkus Cookbook. If you have any question, anything that related with the course or with Java, Quarkus, Istio, Knative, Tekton, all this Kubernetes stuff, then you can ask me on Twitter or in a mail. My Twitter, AlexSotoB. Feel free to follow me, and there you will be updated with all the courses that we are delivering in Red Hat, but also some content that I record, and also the mail for any question is also possible. So as usual, there is this survey link here. I'm going to share you, or your opinion is important. Sorry, and yeah, I mean that. Feel free to just start, giving us some insights about the course. But first of all, let's start with the interaction demo. I need your help, okay? For this course, I'm going to use OpenShift. At the end, OpenShift is Kubernetes because OpenShift is the implementation, is a Kubernetes implementation that's done in Red Hat. And one of the great things about OpenShift is that you are able to deploy a Kubernetes cluster across several clouds and with the same administration window. I mean that if you are into GCP or AWS, Kubernetes, AKS, etc., you see that all of them has a different UI. So it's it's maybe not so easy to manage, but with OpenShift, notice that here I'm in the AWS and this is my cluster and I've got this interface, this Red Hat OpenShift interface, and here I'm just in Azure, as you can see here. Now this is just in Azure, but notice that the implementation is exactly the same. I mean that everything looks like the same thing, although I'm in the different clouds. But now let me show you an hybrid cloud demo. Here is the demo, this is the URL. I'm going to paste it here. So please just try to reach this. And basically this demo is really interesting. What we are doing here is an hybrid cloud demo. Basically we've got one front end and several backends. And each of these backends is in a different cloud. One is in AWS, another one is in Azure, another one is in GCP. All of them running in OpenShift, right? And then of course, this demo can be run with a standard or basic Kubernetes. So if you are using any other Kubernetes implementation, you also can run these kind of things. And basically, this hybrid cloud allows me to send a request. For example, I can say here, Alex. And I said, for example, I want it in uppercase. And when I do the send request, you can see that the cluster who takes the request and do the uppercase and return back the response are in the AWS cloud. Okay, you can see here that in this case we have done 3 requests in AWS. I will leave it you here a bit more time so you can play a bit. I'm just leaving here 15 seconds or so, because then I want to show you one really interesting thing. Notice that the important thing is that it's in Kubernetes, so if you are really interested in knowing how to do these kind of things, then the tutorial is for you. Of course, today we're going to cover the basics, only the basics, so you're not going to learn how to do this hybrid cloud thing, but most of the concepts will be covered. I don't see any more requests yet. Let's wait 10 seconds. Maybe you can see here Barcelona, or from Barcelona, and I'm going to put it in reverse as well. I think that, and notice that here. Okay, now I see that all of you are just starting going to Amazon. Okay, that's fine. Pretty cool, thank you. But now I'm going to the AWS implementation. This is hybrid cloud backend. This is the backend. Okay, and notice that here I see that there is one pod. We're going to see it in the tutorial what is exactly a pod. But now I'm going to simulate a failure. What's happened if I just stop this pod, the pod that is in Amazon? Okay, this could be maybe that the cloud is down or your service is down. Remember that now I've got an hybrid cloud demo, and notice how other people is moving to Azure or GCP. Okay, that's really cool, and this is something that you can easily do with Kubernetes. Okay, then notice that now all of you are going to Azure, and notice that I've not done anything. It's just something that, you know, if you can think about that, the magic happens, right? It's just I have several clouds, Azure, GCP, and Amazon, and I'm deploying this in Kubernetes in the same way, with the same interface. Everything is exactly the same thing, but I'm able to reroute things from one cluster to another. Of course, I could go here and just say, okay, now that everything goes to Azure, I could go down, scale down to 0 the Azure one, so I'm just stopping another cloud. And now, if I do here another one, I can see that my request is done by GCP. So it's really easy, right? And I'm able to have hybrid cloud if you want as a backend or as a backup, right? So it's one cloud is failing, then I can reroute to another cloud and it's done automatically. So let's start with some slides now that you've played a bit with this demo, which is pretty cool. And let's go to the slides. Today we're going to see, or briefly, what is Kubernetes, why Kubernetes, well, installation, you know, it depends a lot on what you're going to use. Maybe you're using Minikube, maybe you're using Kind, or maybe you're using some kind of the cloud provided ones. This depends on your provider, but then we're going to see kubectl, pod, ReplicaSets, the logs, services, Kubernetes services, how to deploy Kubernetes service, and so on. And on next Wednesday, we are going to see how to do rolling updates, which is really important. Liveness and readiness proof, a major topic, which is pretty critical if you want to deploy correctly the applications in Kubernetes, how to build images, and so on. So, why Kubernetes? Well, basically, in the past, and I said in the past, it's like 3 years ago. In fact, probably some of you are still in this old school way, which is not bad, which is like that you've got a really big monolithic application with one database, and then, you know, it was really, or it's really easy to deploy this thing, right? Because it's just one stuff that you deploy it and you maintain. But what's happened when you move to the new school, to this services architecture or microservices architecture? I mean that doing a true microservices architecture are pretty hard, but let's say that you're doing a microservice services architecture, that you have several services, all of them interconnected by the network, and then you want to deploy each of these microservices or each of these services individually. You need a way, an easy way to deploy them, right? You cannot do the same thing that you did with the monolith, because with monolith it was pretty easy. It just was one unit. But now you've got several units, and probably you want to deploy all these units several times per day. So we need an automatic way, an easy way to do that. And this is where or why Kubernetes and OpenShift are really important. So if you remember in the past before Kubernetes, you were deploying your application in this way. You have it just a server hardware, then the operating system. If you're in Java, then the Java virtual machines. Then you've got an application server, a custom configuration, and then inside this custom configuration, which would be the the JDBC driver, the sources, the GMS, and so on. Then we put it there, the var, the jar, and so on. The problem that happened with this is that, well, usually, or it could happen that you add some kind of a slash instead of control a slash in your application, or some configuration that was specific to your environment and not the production environment. Maybe you added there a different JDBC driver than the one that was in the production machine, and this kind of thing. So this is something that we need to cover. And to cover this and to fix this problem, we've got containers, right? Containers is a way to put all this stuff inside. You can think about like a virtual machine. I know that the container is not a virtual machine, right? But if you want to understand it in this way, it's like it's like a virtual machine where you've got everything there. You've got the container operating system, then you've got the Java virtual machine, you've got the custom configuration, the dependencies, and finally your var or your jar file. So notice that now with a container, you are delivering correctly all your stuff, because in each of these layers, in each of these Docker file, you are setting the exact configuration that you're going to see or to use in production. So the thing is that, okay, now I've got one container, then I can do Docker build, Docker run. Maybe most of you have played with this stuff, but now how I can scale this? How can I avoid port conflicts? How can I manage the multiple hosts? How to make all these processes running? Because remember that if you do Docker run and the container dies, then this container is not restarted automatically. How can I do all this kind of stuff? And of course, the answer is Kubernetes. Then Kubernetes, it's the Greek word for helmsman. So it's the governor, right, of the ship. It's in a container orchestrator, supports multiple clouds and bare metal environments. You can run Minikube on your bare metal machine, or you can just use Kubernetes in multiple clouds. You've seen here that I'm using GCP, Amazon, and Azure. And one of the great things about Kubernetes is that you start managing applications and not machines. This means that in the past, usually what you did for deploying was to SSH that machine, right? So you do SSH to one machine, and then you copy some stuff, SSH to another machine, and you copy another stuff. You maintain all the stuff, all the programs, all the software that's in these machines. So it was pretty hard, right? But now with Kubernetes, you are to start managing applications. We're going to see this in the demo. That in the demo you are just deploying applications, and then there is someone at the bottom, in this case it's Kubernetes, who is in charge of deploying these applications inside the machines. You do not care about in which machine, you just deploy, and Kubernetes finds the resources and deploy it there. And why it's important is, well, because in 2015 in Red Hat, notice that Kubernetes was released in 2015, early 2015. Now at the end of 2015, we've got like first version of OpenShift with Kubernetes, and we were able to launch more than 1,000 containers, right, in a Kubernetes cluster. I recommend you that you watch this video, because you'll see how powerful is Kubernetes, right? That you can deploy 1,000 containers at one cluster. One of the or the major things in Kubernetes is the pods. Pods is a group of whales. Okay, this means that if you remember Docker, the logo of Docker, it's a whale, and a whale represents a container. And this is something really important. In a pod, you can run more than one container at the same time. So usually people think that a pod is a container, okay, but it's not true. Remember, a pod is a group of containers because a pod at the end is a group of whales, and the logo of Docker is a whale, right? So this is a way to remember that a pod can have more than one container at the same time. More things that are important for or terms for Kubernetes. The first one is what is a pod. A pod, as I said, it's one or more container, and all the containers inside this pod contains a shared IP, a shared storage, shared resources, and shared lifecycle. So you can think that the pod is the new virtual machine, right? I mean that, please don't say that a pod is a virtual machine, because it's not, but you can think that it's the new virtual machine, that you know, that the new virtual machines for the 21st century, where you deploy things there, as you can see that it's more than one container, and share all the resources. Then there is the ReplicaSet and the deployment. Basically, with Kubernetes, you're able to scale up and scale down any application. So you can say, I want one instance of this service, or I want 3 instances of this service. And then there's someone who is in charge of checking this state, right? Saying, okay, I want 3 instances of this service. Then what I need to do is just find 3 slots on my cluster and deploy 3 instances of the service. This is what is ReplicaSet and deployment. Then there is a service. And notice that the service usually, when you've got more than one instance of a service, this service contains several IPs, right? And you need to be able to route traffic from one IP to another one. And this is exactly the service. You can think that service as a load balancer. It's not like that, okay? Because it does some more things, but you can think that it's a load balancer between me and other pods. That is a stable IP, okay? So every time that I refer to this IP or to this DNS, because it also offers a DNS, then I am getting access to the pod. And then we've got the persistent volume, and then we've got labels. I think that there are some questions. I'm going to check it now before I continue. Can a pod be made of different applications? Well, actually a pod could be that has different applications, but usually when you've got a pod with different containers, you've got your application, your service, and then as other pods, other containers running inside the pod, it's like helping or helpers services. For example, a proxy, or for example, a logger. If you, for example, want to log everything that is happening inside this this pod, then you can create some kind of program that it's just logging everything that is happening and send it to, for example, a logging system. So a pod, well, you know, it's not to run, for example, an application and the database. The reason is that because if it dies, the pod, then it's going to be killed, the application and also the database. Okay, so it's more that you can run one service and then some cross-cutting services around it. As I said, a proxy or a login system or a security system. Suppose that you want to make that all the communication between services happens in HTTPS, then you could create there another container which is in charge of doing all this request and response against other pods, encrypting all the information. So it's not like you've got several business services, but you've got one business service and then some kind of services that helps doing some cross-cutting elements. And I think that there was another one said, what is the purpose to deploy multiple containers on a single pod? No, you said the grouping by common characteristics. No, it's not by it's not for grouping by common characteristics. I just said it's more for yes, as you mentioned. Then it's like metrics, for example. If you want to get the metrics for one pod, then you could create your business container and then another container which it's delivering metrics to your, for example, Prometheus or Grafana system. So you could have one pod with 2 containers, one container having your business service and another container having the metrics stuff. So it's not for grouping, it's more for providing some extra features that are not related directly to your business code. And I remember one question that said if the user that the hybrid cloud demo was using Istio. No, it's a plain Kubernetes stuff. With I mean, we are using one thing that it's called a scupper, but it's not Istio. It's just a small proxy that allows intercommunication between clusters. Okay, then this is the architecture of a Kubernetes architecture. Basically, we've got devs and ops that interact with the master node. This master node contains an API and a TCD and a scheduler and controllers. And then we've got the worker nodes. These worker nodes is the nodes where you are deploying all these pods. And notice that, for example, here I've deployed 2 MongoDB pods on, for example, 3 PostgreSQL pods. And basically, as a dev or setup, I say I want to deploy something, and then you interact with master. And notice this is why I said that that you are managing applications and not machines, because you're just saying to the master node, I want to deploy this application, and then the master node takes care of everything. I'm not doing SSH to any of the worker nodes. And I think that that's all. I mean, let's go to the demo so you can see everything, because we've been doing a lot of slides, and I want to show you some demos. Let's just start with something really fast, and then we're going to go step by step. Basically, what I want to show you is how you can deploy something. So I can do kubectl get nodes, and you see that here this is my Kubernetes cluster. In this case, as I said, it's an OpenShift cluster, but at the end, OpenShift is a Kubernetes implementation. Notice that I am in Amazon, and it's in Frankfurt, this cluster, and notice that I've got, like, I think that it was 1, 2, 3, 4, 5 worker nodes and 3 master nodes. Okay, so it's just for replication. Well, I'm just reading the questions. Do elaborate on health checks? Well, health checks is something that we're going to cover on Wednesday. Basically, health checks are used to know if the container or if the pods are performing correctly or not, if they are up and running, if they are able to accept repos or not. It's just, as I said, it's a health check. It's just to know if the pod is behaving correctly or not. As another example, I'm using 2 containers. Yeah, exactly. This is the Flask example is another one, which you create a proxy to do another thing. Yeah, that's another example, which is pretty cool. Well, I think that you are saying if, well, maybe it's answering, yeah. Yeah, Istio is not an API gateway. Sometimes you can use Istio as API gateway if you want something really, really simple, but usually you've got an API gateway and also Istio. And I think that that's all the questions. Is it correct to say that each container should have a single responsibility, a microservice? Hey Tsu, you're asking me about a single responsibility. Yes, we could say that each pod should have a single responsibility from the point of view of business. Okay, so from the business point of view, a pod should only contain one responsibility. In case microservices, of course, if you are deploying a pseudo monolith into Kubernetes, then this pod will contain more than one responsibility. Okay, but you can think that one microservice is one pod, and then there is, inside this pod, there is the container with the business unit, and there can be other pods inside. Okay, other containers inside, which are not from the point of view of business, but from the point of view of operations. For example, as I said, for example, a metrics pod for capturing metrics, or as I read here, for example, as a proxy, you can create a proxy to another server, or for example for encrypting information, or for logging, or for this kind of or for traceability. In case of this is really clear when you are using Istio. In Istio you can see exactly why it's important to have several pods. For next week there is the Istio talk, and then you will see it easier, because you're going to see a real example. It's okay, yeah. Oh, Sebi, thanks for the answer. Okay, now let me start, because if not, okay, this is my cluster. I'm going to just do a watch kubectl get pod, so you can see that now in my namespace I've got no pods. In fact, yeah, it's okay. It's doing this. Now, let me just go here and let me go here, git Kubernetes tutorial. This Kubernetes tutorial is, as I said before, what you can do it at home. And let me deploy the first application. I'm going to do a create deployment. Deployment, my app, minus image, and I'm setting the image that I want to deploy. I think that it's this one, okay. And now what you're going to see here is that I'm just deploying. I'm just not saying I want to deploy this application to this machine or whatever. I'm just saying create the application. Notice that here, magically, a new pod is created. Okay, well, this pod is being created. Now it's downloading the container images, and then it's going to be started. Okay. Let's wait until it's deployed. But the important thing here, as I said all the time, is that you are not managing machines, you are managing applications. I've said I want one instance of this application into my Kubernetes cluster, and boom, the master node just goes and do the stuff. Now, if I do, for example, kubectl get events, oops, you can see all the events that are happening inside this cluster. This is really useful. Notice that it's just saying, okay, it starts from here. It says that I want a new my app pod and I want to assign it to this machine. And this is something that it's done automatically by Kubernetes. Kubernetes says, you want to deploy this application, okay, I'm going to deploy it to this node. If we do a again nodes, you'll see that there is one node with this IP. Then it creates the pod, scale up to 1 because by default we want to scale to 1. Then it pulls the image. It's successfully pulled the image and then start the container. So now we've got our application up and running in Kubernetes. Now, what's happening if I want to do some requests to this service? Well, one way of doing it is just doing an exec. Okay, exec is like that you want to execute something inside this container, right? So I can just do kubectl exec -ti in this in slin /bin /bash /bin/bash, and now I'm inside the. I'm not in my machine. I'm inside this container. I can do ls. You see that I'm inside our name. That I'm in a Linux, not in a Mac. And now I can do a curl localhost 8080, and you see that since this is a Quarkus application, you see that I'm getting supersonic subatomic Java with Quarkus, and that's cool. Okay, but now probably you're saying, okay, but I want to expose my service to the wall, not just to my local machine, right? Okay, now what you can do is just do a kubectl expose deployment. You said that you want to expose the my app import 8080, and I want to create a load balancer. Okay, so I want to create load balancer. So I want to create or want to expose my Quarkus service to the old wall. So now I can do kubectl expose, and notice that it says that the service my app is exposed. Remember that I said when I was doing the theory that the pods are dynamics and the service are static. A service contains a static IP. So I can do kubectl get service. And you can see here that my service is my app. It has a cluster IP and it has an external IP. Okay, this is the external IP where everyone can access to this service from outside the cluster. If I'm inside the cluster, I can refer by the my app. My app is the DNS name, or by the IP, which is this IP. So if you are inside a pod that wants to make a request to another pod, I can use this IP, or I can use this name, this DNS name, and it's going to be valid all the time. Meanwhile, this service is up and running. Or if I'm outside, like for example you or me now, I can just do a curl to this URL 8080. And well, now it's not yet resolved, and the reason that it's not resolved is because it takes like 1 to 2 minutes to resolve the external IP to the outer wall. It's going to take a bit of time. we need to wait a bit. But meanwhile, I can just show you that if you do kubectl get pods, you can see that here I've got my pod running. Remember that I said that hey, there is a ReplicaSet, a deployment. I'm just reading about this coding. Now I've moved a bit the windows. Hope that now you see. Okay, now I can do kubectl get deployment, and you can see that there is, or you will be able to see that there is one deployment. And there's one my-app, and notice that it says ready 1.1. Basically, it's saying that I want one instance of my-app, and you've got one instance. Okay. Now, let me do a crawl again. And now notice that I'm just having this IP that I'm going to share with all of you. Okay, now if you access to this URL, doing a crawl as I've done, then you'll be able to access my service. So notice that in any case, I'm just managing hardware. It's all the time doing kubectl, and it just works. Now, what's happened if I want to scale up? If I want to create more and more instances, then I can do the next thing. Kubectl edit deployment my app, and now I can go here. Notice that this is the YAML file that it's created automatically when you deploy something, and something over here you will see I'll be able replicas, not replicas. I'm saying that I want one replica. Now suppose that I want to create more than one replica. I want to create 3 replicas. I can just go here, and I put here 3. Okay, and I save, and now I'm going to save this, and the important thing is that you need to check this app window where you're going to see that more pods are created automatically. Notice that I can do this, and notice in a matter of seconds you're going to start seeing here more and more pods. And notice how easy it is to deploy more applications. Let's see if it works. Come on. There's just one pod. Let me kubectl describe. No, get events. Come on. Kubectl edit. Here, sorry. It's this one now. Okay, now you see here how 3 pods are. Yeah, thank you, Sevi. Yeah, I noticed now that I've updated the wrong section. This is the status, and this is the real one. Notice that now I'm creating 3 instances of the same application, right? And if I do kubectl get deployment, you see that now I've got 3. It's saying I want 3 instances of this my app, and the 3 are up and ready. Now you can scale up and down using this kubectl edit, or you can do kubectl scale deployment my app minus replicas, and you set 1 or 2 or whatever. I'm going to put it to 1, and then notice that how 2 pods are terminating and 1 is still up and running. And again, notice how easy it is to manage. You are managing applications, not machines. You can scale up, down in a really easy way, and Kubernetes is the one who just checks the resources, checks the machines, and deploy your pods there. Then what's happening if I want to update my version? Notice that I can still do a call to here, although there are more and less pods. I'm all the time working correctly. And now what's happening if I want to change? I want to change this version of the pod to another version of the pod. So you can think about like deploying a new version of your service. You can do it just doing kubectl set image deployment my app and just the I think that it's Quarkus demo. I think that it's in this way. So I'm just saying that I want the deployment, the Quarkus demo, change it to my boot. Okay, now notice that it's doing a rolling update. It's not a really rolling update because now you're having some kind of downtime problems, but yeah, for now it's okay. It says, Christopher says, how can traffic know which instance will it connect? Yeah, this is done by the service. We're going to see it in a few moments exactly what is a service, but this is because of a service. We've got a service, which is, you can think like it's a load balancer. And then this is the way how it knows. You say, Marcin, how has been this additional pod added? Yeah, it's added. I mean, it's automatically done. I mean that if you do a kubectl get nodes, Kubernetes knows which, I mean that knows all these worker nodes, okay, and it said, okay, I need to deploy a new pod, so I'm going to take one worker node and I'm going to deploy it there. Of course, there is in Kubernetes Kubernetes 3. Master Course 3, which is still not, it will be able on September probably. We are going to show you how you can change where the pods are deployed. You can just do some kind of affinity, anti-affinity things, okay? But for now, think about that. I need to deploy a new pod, just Kubernetes master goes, finds a worker node, and just deploy it there. Then, now we've got another version, and I noticed that I have to do a curl, and now I'm getting Aloha from a Spring Boot. Before that, I was getting Supersonic Superdynamic Java because the version 1 was with Quarkus, the version 2 is with the Spring Boot, and notice that I'm getting the Aloha from a Spring Boot. But notice that the important thing here is that the service, it's always the same. For this reason, I said that this service acts as a load balancer. You asked me how many maximum nodes we can have. Well, the truth is I don't know if there is any limit. The maximum thing that I've seen, I think it was like 15, but I'm sure that this is not the limit. I don't know if maybe, I cannot answer the question, but yeah, I mean, in this case, I've got, the maximum I've seen is 12 worker nodes and 3 master nodes, but I don't know if there is a max or not. Now, okay, now we've got this service. Okay, now let's go step by step because we have seen a lot of. Oh, look, 7 nodes and the max is 5,000. Okay, 5,000 nodes. But notice that each node could have like 4 CPUs and 25 gigabytes of RAM. I mean that this is not a problem. And then I'm funny because you said I just Google it. I thought that you know someone asked you this before and you already know. Okay, now we know something new. Okay, now let's go step by step. Let's do a kubectl delete all minus all. This is one of the things that I do most of the time. It's like, okay, now I want to remove everything and starting from 0. So you do a kubectl delete minus all, and then it just works. Okay, now let's start. Okay, remember, now I'm just doing a kubectl delete all, so I'm just removing everything from my Kubernetes cluster. I mean that everything from the point of view of application. I'm not removing Kubernetes at all. I'm just taking all the stuff that we have been doing in this namespace in this cluster, and I remove it. So now we do not have any application, any pod, any ReplicaSet, any deployment, nothing. Notice that this is terminating. Now this is finished and I can do git services, and you see that there is no services. Kubectl get services. Sometimes you will see that I use these kgate services. The reason is that I've got an alias because sometimes I'm a very lazy lazy guy, and I don't want to stay doing all the time kubectl. So I just created an alias with k, so you can do kgate pods. It's exactly the same as kubectl get pods. Okay, now. Oops, clear. And let's deploy one thing that you can see that it's in this in our tutorial, it's just here. Let me put now, and let's deploy a naked pod. Let me copy this and paste it here. This is a naked pod. It's just a pod. It's not a replica set. It's not a deployment. So it's just a pod. And notice that it's the minimal thing that you can use, which is just say it's a kind of pod. I mean, you can define kubectl create as we've seen before, or you can just use a YAML file, which is usually how people works with Kubernetes. And I'm just saying that I want to run this. I want to start this pod. Let's just starting the pod. Okay, now notice that the container is being created. And now that it's running, I can do kubectl exec -ti again to this Quarkus demo /bin/bash. I can do curl localhost 8080 and just works like before, but remember that now I've just created a naked pod. So I can do kubectl get services, and there is no services, so I have no static IP to access to this pod. If I do kubectl get deployments, there is no deployment. Okay, so my question is now, what's happening if I do kubectl delete pod, this pod? Notice that it's been deleted. Now it's terminating, and that's all. And now you see that there is no more pods here. Hey Aranda, yes, they have a load balancing mechanism. I don't know if you mean Kubernetes in general or services, but I mean that services are not a load balancer per se, but yeah, they have also a load balancer services. For example, if you expose to public, so if you remember when I've done this kubectl, what I said before, set create service. Oops, set service. I know, I can remember. No, it's I think Sebi. Yeah. Exactly, Seb is saying, when you do the kubectl expose, now I couldn't remember, kubectl expose, this, notice that you're saying minus type load balancer, then it takes the load balancer of the cloud provider, and you've got a real load balancer. Okay, notice that now the pod has been destroyed and there is no more pod. So it's not resilient at all, right? Because it's like I say, okay, the pod has died and it's gone. Now, let's do another thing. Let's create exactly the same, but with a replica set. Remember that replica set is the one who is in charge of maintaining the state of the application. So, for example, in this case, I'm saying I want to deploy. This is pretty much the same. Notice I'm saying that I want to deploy a new container, which is Quarkus demo v1, but I'm saying that I want 3 replicas because the kind is replica set. So I'm saying that I want to have 3 instances of this container all the time. This is now I'm just applying this. I'm just creating the instances. Now they are running. But what happened now if I do a kubectl delete pod, and I delete this pod? Notice that one pod is going to be terminated and a new pod has been risen up. Okay, so maybe you've not, we can do it again. I can just delete this. Okay, delete pod, this pod, okay, but notice that I'm deleting, it's terminating, but it's creating another one. The reason that this is happening is because I've got the replica set, and the replica set is, you can think that it's the word that is all the time there checking if the service is running correctly or not. Okay, and if it's not working, then it just kill it and start it again. Or if I kill for any reason, as I said here now with kubectl delete, then a new pod is started automatically. This is the big difference between what we've done in the previous example, where it was a naked pod, it was just a pod, and if the pod dies, the pod has died and there is no restart. Or if you create a replica set, then this replica set, it's all the time, it's like a daemon that it's all the time checking the status of the application and starts again. Then let me show you a new really cool tool. It's like, okay, what's happening if I want to see the log of a pod? I can just take the pod name. This is the pod name. I can do kubectl logs and put it here, the log, and here you can see the log of the first pod. Then if I want to see the pod of this one, I can do a kubectl logs, and then you see the log of the other version. But what's happening if I want to see all the logs of all the pods at once? I can use a tool that it's called Stern. Stern works pretty well. You can do Stern of RS Quarkus demo. And notice that now I'm just watching, or you can inspect the log of all the pods that follows this regular expression. In this case are these 3 pods. Notice that here it's saying that this pod is in blue, this pod is in yellow, this pod is in pink or red, and then you can see each of these pods, the demos at once, right? So it's a really nice way of checking what's happening when you've got a lot of pods replicated. Okay, we've seen Stern, we've seen kubectl, we've seen the pod. That the naked pod is nothing. We need a replica set. Okay, now let's move forward and just show you another thing. Let me do now a delete all. Since I'm doing a delete all, notice that I am also deleting the replica set. Since I'm deleting the replica set, the replica controller, then I am able to delete the pods, because the replica set is the one who is in charge of checking if there is some pod dies and then restart it again. If I'm killing the replica set, then there is no automatic restart. Now, let's move forward and let's see what is a deployment. A deployment is like, you can think like a deployment is over here. Here it is. I can show you here. You see that it's more or less the same, but the type is of type deployment. For now, for this, oops, not here. Well, I can do it here. For now, you can think that a deployment, notice that now it's also with 3 replicas. For now, a deployment, you can see that it's more or less the same as a replica set. I can even kill one pod, delete pod, and it's going to be killed and created again another one. It's just this. But in the next, on Wednesday, you're going to see in the next session, you're going to see that the deployment is something more important, because it allows you to do rolling updates. So you can make a transition from application A to application V, or from version 1 to version 2 without downtime. This is thanks of deployment. Okay, if you don't have a deployment, then you cannot do this kind of thing. For the reason, usually you are always working with the deployments, not directly with ReplicaSet, not directly with the pods, with naked pods, always with these deployments. Now, what's happened? I've got this, and for example, now I want to expose this. For example, I want to expose this service again to of the wall, because now I can just access one of these pods, right? kubectl exec-t. I can go here again. /bash. I can do curl localhost 8080, and of course it works. But what's happened if I want to expose this service to the wall? As we've seen before, I can do kubectl get services, and of course there is no services there. I can create a YAML file. I don't know if in the tutorial it's with a YAML. No, it's not with the YAML. Let me check if you can see any YAML file. Here it is. Okay, I think that we can do it. Now we can create a service. In this case, I'm just creating a service. Let's put it in 80808082. Okay, I'm just saying I want to create a service which is called the service, which you create the selector, so you're putting here which is the application that you want to redirect the traffic, and then you set the port and the target port, you run it. And I can do kubectl get services, and now I'm just creating a load balancer of the service. Okay, I can do curl to this, and it will take some time, but it's going to work. And if you want to see that this look, I'm going here, the service is a DNS name, I can just go here, copy it, do a, it's called the service. Okay, I can go here and can do kubectl exec -ti/bin/bash. I can do curl localhost 8080 I've shown you before, but also I could do curl the service 8080 and also works. Okay, and notice that it also works because this service is a DNS that refers to all these services. And if you look closely to the log lines, you see here, this is the host name. I mean, not the host name, I mean, yeah, the host name of the pod. Okay, and see that this is one pod, this is another pod, and this is another pod. So you can see that the service, the DNS, is working as a load balancer. If I run it again, this is another worker node, and then it's repeated. Notice that this hostname and this hostname are exactly the same. Okay, so you can see how a service works. Now, this thing's working perfectly. Let me show you in deep how a service works, okay? Because it's really important to understand the service, because now you've seen that the service acts as a load balancer, but probably you are asking yourself, okay, and now how I know which service are baked by which pods? So you've got some pods in my cluster, and I want to know which services, or how to detect which services works against which pods, right? Which are the baked ones. So let me do a kubectl delete. Up here, kubectl delete all -all. So can you attach the word to a container? Yes, you can attach it to a container. There's no problem. And even you can use one tool that is called telepresence. If you Google it, telepresence, you'll see that it's a really nice tool to attach the debugger from your local machine to a remote cluster. So yeah, you can use telepresence, or you can expose the IP and attach a debugger. Yeah, it's not a problem. In fact, I think that there are some demos out there from our team which are showing you how you can debug an application with done in Quarkus with live reload mode as well. So yeah, you can do a lot of things with this. There is no nothing that forbid you to do these things. Okay, then now that we are empty, let me show you the service. What's one thing that we call the service magic? Let's deploy some services. I'm going to deploy a Python service. Okay, this is a service that is done with Python. Let's see if it's deployed or what. Yeah. Then we're going to deploy one that is done with Go. I'm going to deploy it. And now another one which is with my node. Now let's wait. Notice that I'm just adding a deployment, a type of deployment with just one replica, and this container, which is my node, and the container port is the 8000. Okay, so now I've got 3 services running. Remember, there is no service yet. Okay, well, now it's creating this. It's going to take a bit of time, but it's going to work. Let's see if it works. Okay, get deployments. Kubectl get deployments. You can see here, for example, that my node deployment, we want 1 instance, and we've got 0 instances yet. Now, when I'm running this, notice that this 1, 1, 1, 1, 1. So I've got my applications up and running there. I can do kubectl get services, and there is no services. Okay. Now, let me do the next thing. Let me add this. So I'm creating a new service. Okay, now I can do kubectl get services. In theory, you would say, okay, this service is pretty cool because, wait, let's see. Now I've got this IP, this external IP, my service, so on. But if you see here, my service, I put it no selector in service my pods. What I'm saying here is that my service serves all the pods who has a label with in service as a key and my pods as a value. Now, what's happening if I do kubectl get pods minus minus show labels? You can see that my Go application just contains these two labels: app my Go, app node, app my Python. Yes, and if I do kubectl get services minus I think that minus show labels also works. Yeah, notice that here this is the label with app my stuff, and if I do kubectl get service my service minus o YAML, I'm just checking the content of my service, and if you see here the selector, I'm saying in service my pods. So as there is no pod containing a label in service my pod, because remember, I can just do it again just in case. Show labels. Notice that I want in service my pods and there is no in service my pods. Now, if I do, this is the host name. If I do a curl, this is saying that empty replay. Okay? Because basically this service is not baked by any pod. Now, how can I change this? Okay, I can change this by changing the label in these pods. Okay, I can do, for example, kubectl label pod, label pod minus L. The application my Python, this is, I want to add it this label. Okay, I can just, if you want, watch kubectl get pods minus show label. Okay, now notice that I'm saying that I want to take the application my Python with label app my Python, which is this one, and I want to add this label. Now, if I run it, you'll see that this is updated. Notice that now I've got two, yeah, I've done this, my Python, and notice that here, now my service is in service my pods and app my Python. Now, what's happening if I do a call again? Oops, it's 80, wait, because maybe it was not the 80, 1 second. Yeah, it was the 800. Probably the DNS is taking more time than expected. And now, okay, now notice that I'm getting the Python, okay? Now, what's happening if I want to start doing a load balancing between my Python and my node? Well, the only thing that I need to do is do a kubectl label pod minus L app equal my node in service my pods. So notice that now my node is going to also have in service my pods. So now when I do this curl thing, I'm getting from node, I'm getting from Python, I'm getting from node, I'm getting from Python. And again, if I do kubectl label pod minus L app, let's move that my Go into my pods. Now, notice that all of the services, all the pods contains the in service my pods. So now when I do a curl, I'm just getting Python and Python and Go, Python, node. Okay? So this is how a service works. A service works with a label, and you just need to specify the label from the pod and the label in the service. So if the labels are not in the service, then this service is not baking these pods. This is how it works. And notice that now it's really easy to do some kind of blue-green deployments, okay? Even, for example, I could do kubectl So you see here, nope, I could do a patch to change the service if you wish. Another way to that it works pretty well is doing a kubectl describe. Kubectl describe allows you to see some important information. Notice that now I've got this my service, okay, and when I do the describe of this service, I'm checking all the information, this type of load balancer. The selector is in service my pods, so here is where I can see that all the pods that are with the label in service my pod, it means that it's going to be served by this load balancer or by this service. And if you check here endpoints, notice that there are 3 IPs. The reason that there are 3 IPs is because these are the endpoints which this service are serving, right? So for example, I can do now, I can do this, I think, kubectl get deployments, and I can do kubectl scale deployment. Even if I change my Go deployment to replica 2, notice that it's been a skeleton. I can do get pods again. Notice that it's creating this one. We are almost done, so no. And I'm going to with answering some questions, but I think that Sevi has done a really, really nice work today. So thank you very much, Sevi. Now, notice that there are 2 my Go's and my Node and my Python. I can still do curls, and you see that there is one Go, there is the other Go hello world. Notice that these are different instances all the time. Yeah, then it's Python, Node, Go, Node, and Python. So it's all the stuff here. But now when I do a kubectl describe, now notice that I've seen that are baked by 4 IPs. Okay, 1, 2, 3. Now it's 1, 2, 3. Yeah. Now this is happening because probably the second instance it's in the same machine, so it's not added as a new pod. Okay, because remember that at the end we've got some nodes. So as you can see, important things of today. It's like 1, a naked pod is not restarted automatically. 2, deployment. It's used to make things be automatically managed by Kubernetes. So if one pod dies, it's restarted automatically. You can replicate or you can scale up and down with an easy command. You can think about like a service, like a load balancer that groups pods, and depending on the levels, you can start playing with services and serving more than one kind of pod. So you can say, I've got all this group of pods and I want to be served by the same service. You can do it by playing with the levels. And pretty much that's all. Remember that you can use Kubernetes with you can create using kubectl create, or you can use the YAML approach. This is up to you. And it's pretty much all. Remember that also we've got some books out there. For example, introducing Istio, but the next week we've got the session of Istio. So if you want to learn Istio, come next week. We've got also the microservices for Java developers, and we also have the book of Kubernetes patterns. And also the Knative Cookbook, which is pretty advanced topic. So if you're used to use Kubernetes, then Knative Cookbook could be a really good option. And all of these books are free. You just need to register to developers.redhat.com and then just download it. And that's all. I'm going to check if there is any questions. Is there any way to find the wrongly updated the syntax in ReplicaSet file? I don't know. I want to find wrongly updated the syntax. I'm not sure about this, about the airbag, but it should be possible with the describe. If you do at the end, a describe I mean that for example, if I do kubectl get pod, you see that I've got all the pods, and I can just select this pod and do kubectl describe pod. And I put it the pod, and I can see all the information, all the description of the pod. And if it's failing, I can see here why it's failing. Okay, I could even make it fail this pod, and then here you can see the error message. So probably when you do a kubectl describe is where you can see everything. Of course, as Sebi said, if the answer is that of the syntax, I mean that the YAML is wrong, then you will get it from when you apply the resource. Notice that, for example, I could do this. I can show you. Oops, wait. I could do this, and for example, instead of service, suppose that I misplace something and put service CE. If I done it and I try to execute it, see that it said unable to recognize, no matches service, the kind service in service one, and the same for any other stuff. I mean, it could be service on, it could be, for example, instead of a spec, saying spec, for example. Then I can run it, and it will say that, again that there is a known field spec and so on. So I mean that if there is a syntax problem, then you can get it from there. If it's more a semantic problem, not a syntactic problem, then with kubectl describe you will get it, the errors. Shulan says, will be the deployment of Kubernetes for multiple data centers covered in this course? No. Yeah, I suppose that you mean multiple data centers with, for example, different regions or different cloud providers. No, it's not covered, but yeah, there is a specific tool for OpenShift to do that. If not, then you can just do kubectl. You can do kubectl, and there is an important thing that is this export, right? When you do export kubeconfig, you are setting where these clusters are. Okay. Then, if you do export kubeconfig in this window, and you point out to the kubectl or the Kubernetes information of cluster 1, then every operation goes to this cluster. And then you can go to this other window and do export. In this case, notice that I've got it some different. For example, in this case, it's my for Azure. So if I do export kubeconfig, notice that now I can do kubectl get pods and say there is the configuration is it's wrong because I'm just pointing to a Kubernetes cluster that now it's down. But if I do again export kubeconfig to my current AWS and I do kubectl get pods, now I'm getting the result from the pods. So if you are multi-cluster and you want to do this, then you can just use the export kubeconfig. Of course, if you're using OpenShift, then there is a tool for making this multi-cluster thing works, in an easy way or from the UI point of view. And then, yeah, I think that some of you are asking me for the slides. The link of the slides, I can put it here. I think that this is the direction. Is there a link to a tutorial? Yeah, the tutorial. Yeah, well, I'm going to post it both links too. Are there any standard ways to store your replica account outside of Kubernetes? So how do you back up and restore all the configuration? Well, basically, hey Clinton, basically, no, you cannot back up. I mean, cannot back up. No, maybe it's not the answer. At the end, remember that what you want to use is the YAML approach, not this kubectl approach. If you see here, I'm creating this YAML file here. Basically, I could do this. Wait. This is the YAML file, okay? I can just copy this. And let me, for example, let me do a delete. Delete. All minus all. Let's see if it's. And now in a few moments, I can just create here, for example, k.yaml. I'm going to put here the file. Okay, now if I do a cat, you can see that this is the file, and now I can do kubectl apply -f k.yaml, and now it's just the okay, look, I'm getting an error where, yeah, probably I've copied, I missed, I missed one line, the first line. No. Or maybe I know what I missed, or what I added this now. Okay, now I can do kube apply -f k, and I'll notice that I'm just deploying kubectl get pod. I'm just deploying my 3 instances of my Quarkus demo. Okay, so you can store these YAML files in your GitHub repo, and then you can just apply it, and this is where you are storing all the current configuration. Okay, this is the basic answer. Of course, you can start using some tools like Argo CD, which are basically Argo CD. It's just inspecting this automatically. It's monitoring these YAML files, and when they detect a change in the YAML file, then it applies automatically the change, right? But this is, it's another tool which is not provided by Kubernetes itself. So basically, as Sebi said, if you want something, if you want something more dynamic, then you can use the Kubernetes API for accessing to all the stuff, or you can just add all these YAML files in your Git repo, so you know exactly what is deployed there. And I think that's all the questions. But again, remember that on Wednesday, we've got the session number 2. If you have questions regarding this session, I will be very happy to answer on Wednesday, or again, Twitter or email. It's also a possible solution if you've got a really quick question. Thank you very much, and see you on Wednesday.